So in this next tutorial, I just want to go over something called half-life, which basically is just the time it takes for the reactant concentration to decrease to 1/2 its initial value. Usually we talk about half-life when we deal with radioactive materials, because you want to figure out exactly how long these particular materials are going to last. Now, in order to be able to figure something like this out, we use the equation of time equals 0.693 over the rate constant. So it seems like it's a relatively easy calculation. One thing that you do need to keep in mind though, and you'll be able to see this in some of the future problems that we're going to do, it's just the percent of decomposition you're dealing with and how many half-lives will expire during that time. So I did provide you with the table to be able to show you that, where if you're talking about 50% of a particular reactant decomposing, that means you've gone through 1 half-life. But then if you were to keep decomposing after that, to 25%, that's half of 50, so that means you've gone 2 half-lives. Then if you go another half, for 12.5, you've gone 3 half-lives. Go another half, there's 4. Go another half, there's 5. So this is just a way of being able to figure out how many half-lives you've actually gone through, by looking at the percentage of decomposition that you have left. So for instance, let's just go over an example of how to do this. In this case, they give you the rate constant of 9.2 seconds. They want to know the half-life of cyclopropane, which if you're talking about 1 half-life, you're talking about 50% of this being decomposed. So the simple way of doing this is just basically T equals 0.693, and that's over your rate constant, which in this case is just 9.2. So if you do out that math, you end up with 0.075 per second, and that's going to be your half-life in this case. Now you want to know how long it's going to take for this concentration to decrease 25% of its initial value, which means that now you're going another half-life. It's not just going to be 1, it's going to be 2. So if it's going to be 2, take the 0.075 and multiply that by 2. And that should give you 0.151 per second. So initially you went and determined how long it would take to have 50% of the cyclopropane be left over, which you saw is 0.075. Then it asked, how long would it take for 25% of that to be left over, and you figured it out to be 0.151. And again, the reason why you multiply by 2 is because of the fact that you just went 2 half-lives and instead of 1. So let's go over another example. In this case, they give you the rate constant of 4.5 times 10 to the negative 6. They want you to give the half-life in hours. So that means, how long is it going to take for you to have just 50% of this particular substance to be left over. So to do that, you just do T equals 0.693 over the rate constant, so 4.5 times 10 to the negative 6. So in this case, it would take 154,000 seconds to be able to do this. And the reason why it's seconds is because your rate constant is given to you in seconds. So in order to be able to figure this out in hours, it's just going to be 154,000 divided by 3,600, because that's how many seconds you have within an hour. And so this comes out to be 43 hours. So basically, again, it's going to take 43 hours for you to have just 50% left of your particular compound. Now, though, it's asking how long is it going to take for you to have 25% of that compound left over. So that means you didn't just go 1 half-life, now you're going another half-life. So multiply that by 2, you end up with 86 hours to be able to get that. Now for the next one though, now it wants to know 12.5%, how long is it going to take for you to have that amount left. So in this case you didn't go 2, you went 3 half-lives, so you multiply it by 3. Put 129, and you just keep on going with this. 6.25 means that you went 4 half-lives, And then for the 3.125, that means you went 5 half-lives. So just keep multiplying it. So this would take 172 hours, and then this one would take 215 hours. So again, basically, it's just going through, what is it initially for one half-life, and then after that, how long is it going to take for each consecutive half-life.